This is part 3. Here we talk about the power rules. So if we notice, we have a to the m to the power of n. Again, this is how they would write it in a textbook. Notice that they put the m and the n together. What they're really doing is we are going to multiply. So please write that on your paper. What I like to tell kids is ignore what is here. Imagine we can't see what is in there. I know that this parenthesis has a power of 4, which means I'm going to have a total of 4 parentheses. Inside of each of those parentheses was an x to the third. So then the question is, well, how many x's do I have altogether? 3 plus another 3 plus another 3 plus another 3. Well, that's 12. But I don't want to always have to do all that work and all that showing. I can just say, hey, 3 times 4. That's 12. So here, what's 2 times 5? That means I would have a total of 10 5s. The other thing that's important to know with the power rules is there's 2 more things, is that they distribute to everything on the inside. So that n has to go to both pieces. Most people get part of this right, but they don't get the entire thing. So I think a lot of kids will understand, hey, there's now going to be 5 times 2, Gary, that's 10. There's 10 y's. 4 times 2, there's 8 x's, but they're missing something. How many 2's were there? There was a 1. Remember, mathematicians are lazy. They're not going to write that. So now 2 times 1 means I now have 2 2's. That piece gets missed every time. The last one, again, is the same idea, except it's a fraction. It goes to everything on the inside. That won't change. I encourage, if a kid sees a number, to put a 1 there. That's the piece that I think gets missed the most. 3 times 1, 3 to the third. 3 times 3 is to the 9, and then 5 times 3 is 15. To me, the answer. Some kids might say, oh, Gary, what can I do? What is 3 times 3 times 3? You're good. If you want to say 27 m to the 9 over n to the 15, that's great. I'm not overly worried about that. Again, we could have said that was 4 up here. I'm not worried about that. I want you to see the big idea of what's coming to the inside. Okay. 6 questions down there. Show me you can handle them. That's ultimately my goal. I'll take on the 2 crazy ones. I'm not trying to give you all the real hard stuff. You know that. This 3, there's 2 groups here. This 3 has to do with the front part. 3 times 3 means I'm now going to have 9 of them there. 3 times 5 means I'm now going to have 15 of them there. 5 times 2 means I'm going to have 10 of them there. There is no number there. I got to put the 1. So 2 times 1 will be x to the second. The last piece there is, well, what can come together? I have 15 x's and 2 x's, which means I really have 17 x's. And I have 9 y's and 10 y's, which means I have 19 y's. It's a crazy answer, but that's the answer. Let's see if anything fun happens on this last one. I got negative powers. I got all kinds of stuff happening. Let's start. 2 times negative 2. Okay, that's negative 4. 2 times 3, that's 6. Some people might here want to write that on the bottom. You can, but you don't have to. If I come on here and say, well, these were no power to powers. They're just next to each other. What can we put together? Well, let's start with the x's. My numbers there say negative 4 plus 5. Well, negative 4 plus 5 is 1, which means my final answer would be an x to the power of 1. What happens to a positive 6 and a negative 6? 6 plus negative 6 is, and anything to the power of 0 is 1. My final answer here is just the x. The y's went away. On the back of this is your exponent review. There's a total of 18 questions. I'd be happy to do some with you. See which ones you can handle first. I like this top part. This is what the book says. And if you really hate this assignment, I got a coloring page that looks at some questions in a way of matching. Good luck. Do your best.